This short video looks at the quadratic formula, one of the really key pieces or key tools that we need in algebra for Year 10 extension, and then Year 11 and 12 math B and C. Flows all the way through. What I'm going to hopefully explain is not just how it gets worked, but why we use the quadratic formula, why it's so valuable to us in our toolkit. The quadratic formula that we're going to try and solve is got it's x squared plus 5x plus 6. And for now we're sticking to straightforward examples. The coefficient in this case of the x squared is 1. And that certainly makes the solution of these things a little bit easier. The other thing we've done here is deliberately chosen numbers that just have positives in it so that we can focus on the process without getting all caught up in crazy numbers. It's worth just, and it's a bit of advice I give over and over and over, when we're dealing with curves, functions, and trying to understand patterns and behaviours, Desmos is our best tool. Okay, Desmos on the PC, on your iPad, whatever, quickly allows us to sketch the desired function and identify for ourselves that the intercepts are at -2 and -3, and the y-intercept unlabeled at this moment is 6. Desmos, your calculator, is telling you that, and part of the toolbox we need to work with is to be able to come up with those values ourselves without relying on the calculator. The quadratic formula is one of our top 1 or 2 tools to work through with that. So the purpose of the formula is to work out where this function intersects the x-axis. So we are using this tool to find those x values there, and in our case today we're going to find that it's -2 and -3. There are examples where the quadratic formula doesn't cut the x-axis. You could have a quadratic that does this. Okay, so it'll have a y-intercept at this point here, but no x-intercepts. Okay, and in a later video we'll talk about what happens inside the square root sign. That means there's no possible answer. You can probably tweak to that yourself. There's also the slight possibility that a quadratic can come down, just touch, and then come up. In this case, apologies, the drawing is a bit wonky, but in this case here, at that very point, there's a single intercept. And again, we'll have a look at the quadratic, have a look at the square root sign a bit later to see how it is that you can get one solution to these things, not 2. Okay, but for now we'll press on. So the purpose is to find ourselves the places where a quadratic cuts the x-axis. The way we aim to work with this is to say, well, we will be cutting the x-axis when the y value is 0. So our aim becomes, let's find the values of x that allow this expression here to be true. So we're going to find the values of x that allow x squared plus 5x plus 6 to equal 0. Our preparation work for that, for the quadratic formula, is to identify what a, b and c are. Now a and b and c are the coefficients that you would refer to on each of these terms. We make sure we arrange it in decreasing magnitude of power of x. So you have your x squared term, then your x, then your c term, and the pattern then is to just pull out the 1, the 5 and the 6 as your a, b and c values. And then we're going to go ahead in a moment and put them into our formula and see what we get for the results. Now to go ahead and use the actual quadratic formula. So for those, the formula is actually here now. X is equal to this combination of a, b and c. Okay, negative b plus or minus the square root of b squared minus 4ac all over 2a. So It's the square root of b squared minus 4ac. Okay, there's a plus and minus sign in there that you can't ignore, and it also is true that the entire fraction, okay, has 2a as its denominator. So it's negative b plus or minus the square root sign all on the numerator with 2a on the bottom. To solve these things, we insert our a, b, and c values, okay, into the expression, and the substitution is done here, okay. And it's worth noting, really important, that this x that's hanging over here on the side isn't just there for good looks. The purpose of the x is to remind us that we are determining an x value as our answer. The x value we're going to get here is the x coordinate of the intercept, okay? And we hope, or we expect, that we're going to get two answers there. So really important stuff over here. I've noted those 3 points, A, B, and C, where they come from. We must bear in mind that x is not just some trivial thing we're trying to find because a teacher told us to do it. X is the point at which, or x is the intercept on the x-axis, and that we can have a plus and a minus answer, or more to the point, we can have two answers, and the working will work through that. So over here we insert A, B, and C into the requisite parts of the expression. We'll deal with negatives later, but you do have to be mindful that if you're squaring negatives, we handle that. Also, if you've got a negative a value, you've just got to be mindful that you might have a negative value where you've got -1, and also a negative c value can affect that. And ultimately, if you've got a negative in the last half of the square root sign, you may find yourself having to adjust the sign in the middle of the square root there to plus. In any case, in our example here, we get the working as shown. The square root sign, you'll get square root of 25 minus 24. Nice and quick maths, I guess, in a way. You get the square root of 1. So we get -5 plus or minus the square root of 1 over 2. Notice throughout this, in these steps here, I've kept the plus and minus all the way through. That remains a really, you just don't leave that out. That's a really important part of the solution, that we preserve the plus or minus symbol in the middle there. We get ourselves down to this line here, okay? And this line represents as far as you can go without processing that plus and minus in the middle. And then I think a reasonable way to set this out then in your books is to put a line down the middle here. And because the maths is relatively straightforward, from here on in, it's a reasonably simple fraction question. There's room on your page to do the two questions in little sub-columns. And what it does is it reminds us is that these both solutions here, these two solutions that we've got, are equally as important. It's not the case we just take the one on the left and say, oh, that's close enough. You may very well find that, in fact, the one on the right, when we do modelling and problem solving, the right one might be actually more meaningful than the left one, or vice versa. But both are just as meaningful. But in any case, the difference between them is over here I've chosen, I'm going to work out the plus version of it, and over here I'm working out the minus version of it. So then we stick with our working, we go through and we get two answers at the bottom, x equals -2 and x equals -3. The good news is that's consistent with what we said we would get. Desmos doesn't lie, and neither does the quadratic formula. So, consequently, we've got two solutions. We've got two values of x that make the y value 0. So over here, x is -2 and x is -3 are in fact solutions to the equation, or the expression 0 equals x squared plus 5x plus 6. That is to say, if you put -2 into that right hand side, you'd get 0 as your answer. If you -3 in, you'll get 0 as your answer. So you could nominate the two coordinates, if you will, of intercepts. One would be x equals -2, but the y value would be 0. Okay. The other one, okay, could be the -3. And it also has a y value of 0. Okay. Two possible answers are what we're talking about here. Purpose of the quadratic formula again is to find the two intercepts, and that's what we've done down here. It's -2 and -3. Hope this one was useful. Any questions, remember to come and see me. Don't sit on this stuff. It's really important that you catch on to it. and hold it in your medium and short-term working memory, because the quadratic formula is one of these things that we need to be able to grab at any point in time and use it. So don't let this one slip. Thanks guys.